Hello, this is Mr. Rasmussen with Algebra 1 and Lesson 92. In this lesson, we get our first distance problem. Now, depending on how far we go with this in Algebra 1, there are 4 different scenarios, and this is the first one, which is where you have a distance is equal to a distance. If we were to put that into a diagram, it'd be like having a starting point and the first person going and ending, and then the second person going and ending at the same spot, so the distances that they both traveled are the same. Or it could be like have one person go to a certain place and then come back, and so the two distances they travel going and coming back are the same, so we can make them equal to each other. A distance can be also written as a rate times a time. So a rate like 5 miles per hour for 1 hour would be 5 miles as a distance. So we can rewrite this d equals d as rate times a time equals a rate times a time. And this is the first scenario. So let's look at example 1 here. On Tuesday, we had an express train made the trip in 12 hours. On Wednesday, the freight train made the same trip, so that's there. They're both doing the same trip, kind of with those 2 hours there, in 16 hours. Find the rate of each train if the rate of the freight train was 15 kilometers per hour less than the express train. Okay, so I suggest when we work these out to be able to write out our equation, and then we'll fill in the values below it. So it's a rate times a time, and we'll do that as E for express is equal to the rate times the time of, and we'll do a subscript F here for freight train. Okay, so what are we told? Well, we're told that the express train took the time of 12 hours, so I write that below the T for express, and then the freight train took 16 hours. All right, then I don't know what the rate of either one of them is, but I'm giving a relation between the two. So I'm going to write that the rate of the express train is equal to the rate of the freight train. I know that's not true, but let's use what they give us to make that true. So they told us that the freight train was 15 kilometers per hour slower. So if I add 15 to the freight train, it now makes it equal. So that sets me up really nicely to be able to put this in for express train in substitution. So I'll put that in like this, and then just bring the rate of the freight train down because I now have the same variable, one variable to be able to solve for. Okay, I'm going to remove my parentheses so the 12 gets multiplied by both of these terms. So we get 12 rate of the freight train plus 15 times 12, which is 180, is equal to my 16 times the rate of the freight train. Let's subtract 12 both sides here. Be able to eliminate, so I get 180 is equal to 60 minus 12, looks like 4 times the rate of the freight train. Divide both sides by 4, 180 divided by 4, and it looks like my freight train is going 45 kilometers per hour. If that's what my freight train's going, then my express train was 15 kilometers per hour faster, so 60 kilometers per hour for the two answers there. All right, let's look through the second example, and hopefully that'll help you catch on. Once again, here we got girls hiked to the lake 10 killer at 2 miles per hour. And they must have been worn out because then Mr. Ali gave them a ride back home at 12 miles per hour. Not a very fast ride, a golf cart or something. And so if we illustrate that, we have them going to the lake and then them riding back. Nevertheless, it's d equals d, so we have the rate and time equals the rate and time. Let's do, they do headed out, they do H for headed out, and then R for return. Okay, so we know the rates. We know that they were walking at 2 miles per hour, and then they rode back at 12. What do we know about their times? Well, it says, find their hiking time if it was 5 hours longer than their riding time. Okay, so if we write what's not true, the time of the heading out is equal to the time of the return. Heading out took 5 hours more, so if the smaller amount of time is the riding, so we got to add 5 to the ride to be able to make it the same. Sets us up really nicely for substitution. So take out my time headed out and put in my time of riding there, and then bring down my time of riding. All right, remove my parentheses by distributive property, multiply my 2 into both terms. I get 2 times time of riding plus 10 is equal to 12 time of riding. Let's subtract time of riding 2 here. I get 10 is equal to 10 time of ride, divide by 10, divide by 10. It looks like my time of riding is equal to 1 hour. Okay, so if my time of riding was 1 hour, then what was my time of heading there, or riding? Return. My time of heading there is 5 hours more, so that would be 6. And then it asks me, as a follow-up question at the end, how far is it to the lake? Well, I need to substitute this in for one or the other. I can either take my 2 miles per hour and substitute in my 6 hours, so 2 times 6, which is 12 miles, right? Or I could take my 12 miles per hour and substitute my 1 in there and get the same answer, but it is 12 miles to the lake. Okay, hopefully that is a good explanation of how to do that. Feel free to look at the third example and walk through that in the book. I'm going to go to the 2 practice problems. All right, I really encourage you to attempt these on your own and then check your answers, as this may be a little bit newer for you as far as something here in mathematics. All right, practice A. Practice A, we got Candide and Paglos walked to the site of the disaster, wonder what happened, in 9 hours. The next morning they jogged back home in 3 hours. How far did they jog if they jogged 4 miles per hour faster than they walked? Okay, so if we put this in a diagram, once again, they go and they come back, which means D equals D, which means a rate and a time is equal to a rate and a time. Let's use W's for walk and J for jog. There we go. Okay, so we're told the times. It took 9 hours to walk there and then 3 hours to jog back the next day. And then what does it tell us about our rates? Well, the rate of walking, rate of jogging, we know they're not the same. They jogged 4 miles per hour faster. So let's add 4 to the walking, the slower amount, to bring it up and make them the same. Then that works really well for substitution. So that gets substituted right in here. And then I can bring my rate of walking down. And looks like we'll solve for the rate of walking. So remove my parentheses. Gives me 3RW plus 12. And 9W over here. Let's subtract 12 from both sides. It's going to give me a negative number. That doesn't sound right. The rate of walking. Minus 12 gives me negative 3 rate of walking. All right, and then equals 3W. Divide both sides by 3, divide both sides by 3. It looks like we get 1 for the rate of walking, and that is incorrect. I have a mistake in here somewhere. Then give me a moment here. I'm going to see what I have wrong. Oh, there we go. I'm subtracting the 12. The 12 is not the same rate. All right, there we go. Probably laughing at me as you watch this. All right, here we go. This one, done a lot of math so far today. All right, this one right here is the like term. So subtract 3, subtract 3. All right, there we go. So we get 9 times the rate of walking is equal to 12. Divide by 6, divide by 6. The rate of walking is 2 miles per hour. And that makes the time of jogging, if the jogging was faster, it looks like that makes that at 6 miles per hour. And so then we ask ourselves, the question is, how far did they jog? So I got to plug one of these back in. So I can either plug the 2 back in for the rate of walking, 2 times 9, 18 miles, or I can plug the 6 back in and multiply it by 3 and get 18 miles is the answer for practice problem A. All right, practice problem B. On Monday, Voltaire drove to town at 60 miles per hour. On Tuesday, he drove to town at 40 miles per hour. So, both going the same trip. So, rate times time equal rate times time. We're told the rates going there. Let's put some subscripts in here so we know what's going on. They put M for Monday's trip and T for Tuesday's trip. Okay, Monday's trip, he was at 60 miles per hour. Tuesday's trip, a little slower. Must have been some traffic at 40 miles per hour. Okay, if the total time of traveling for both trips was 15 hours, how far was it to town? This one looks a little different. We're actually going to do the time of Mondays plus the time of Tuesdays is equal to the total for both trips, which is 15 hours. All right, so then this one's not set up real well. I got to move something around. I'm going to subtract the time of Tuesday from both sides, and now I'm set up for substitution. So I'm going to take that in for this first one. So parentheses, instead of time of Monday, I'm going to put in 15 minus time of Tuesday. And notice just how we had to add the 2 together to get the total time, and then bring the time of Tuesday down. So 60 times 15 is 900 as I move my parentheses here, times 1. All right, my parentheses are now gone. Let's take this negative number and add it to the other side. So let's add 60 time of t to both sides. Looks like 900 is equal to 100 time of t. Divide both sides by 100, and it looks like 9 is my time on Tuesday. So it took 9 hours. Okay, so if it took 9 hours on Tuesday, how much time did it take on Monday? Well, I got 15 minus 9, so Monday is going to be 6 hours. And there are my answers for that. But as I keep reading, it says, if the total time of traveling, how far was it to town? So these are actually not the answers it's looking for. It want to know is how far. Well, I plug it back in. I can take my 6 times 60 and get my 360 miles. Or I could take my 9 times 40 and get the same answer. All right. Hopefully, even though this might be a little newer for you, it is pretty straightforward as far as writing the equation and filling in the values and doing your correct math. Feel free to contact me if you have any questions. And once again, have a great day.